Now finally we're going to put this thing together. We found out that A0 is minus 2, right? A0 is minus 2. AN is 0. So for us, we're not going to have this term here. So we'll forget that one. And Bn is 2 over n pi, and it's minus 2 over n pi when n is even, and it's going to be plus 2 over n pi when n is odd. So how is that going to look? Well, it's simply going to be like this, right? F of t, A0 is minus 2, so we have minus 2 over 2, that's just going to be minus 1, plus the sum of all these terms from n equals 1 to infinity, right? N equals 1 to infinity. So we can just start listing them out. Term 1. What's term 1 going to look like? Well, term 1 is for term 1, n will be equal to 1. So n is going to be odd. So term 1 is going to be Bn is going to be 2 over n pi times the sine of 2n pi t over big T. Now big T is equal to 2 for us. T is equal to 2, so that cancels with this. So I can tidy that up a bit. We can rewrite that as sine n pi t. And the next term then, term 2, is going to be even. N is going to be 2. So Bn is going to be minus 2 over n pi times the sine, and this other bit here is the same, it doesn't change, so it's going to be n pi t. Term 3 is odd, so it's going to be positive, plus 2 over n pi times sine n pi t, and so on. Now if you got as far as that in the exam and you ran out of time, you'd be doing okay. You'd have nearly all the marks anyway, right? We're just going to go a bit further and tidy it up to make it look fancy. So minus 2 over 2, that becomes minus 1. Now you see this 2 over pi is common to all these terms, so we can factor that out. So we're going to bring that outside the bracket. 2 over pi times sine n pi t over n pi. And the second one is just going to be a negative version of that. Now, don't ask me what this is for, but anyway, so next one is going to be positive, and so on, right? So you can see, what did I do there? I shouldn't have had the pi in actually. I'll go back there again now, 1 second. Ignore all that. Right, so we've taken out the 2 over pi. We've taken out the 2 over pi from each of these. So we're just going to have sine n pi t over n. The next one is going to be minus sine n pi t over n, because that's the even, that's n equals 2. And the next one is n equals 3, so it's going to be odd, so it's going to be positive, plus sine n pi t over n minus, and you get the picture, and so on. So that'll be the full series then. And of course we could take out the n, couldn't we? I think we could take out the n in similar fashion. No, we can't take out the n, because the n, why can't we take out the n? Why can't we take out the n? Anyway, the solution I was looking at, the n wasn't taken out for some reason, so I'll leave it in there anyway. I'm talking about the n below the line. Well, of course, n is going to be 1, 2, 3. That's why we can't take it out. So, to take account of this switch in sign, we can use this, use a little structure here. And it goes like this. Minus 1 to the power of n plus 1. You see, when n is 1, when n equals 1, this thing here gets squared and it's positive, right? When n is 2, that becomes to the power of 3. It's an odd power, so you end up with -1, +1, -1. When n is 3, the power becomes even, so we have a +1. So that gives us a +1 for the odd ends. You see that? +1, there's the odd end there, and there's the odd end there, because that's n equals 3 and that's n equals 1. So we can rewrite our series -1 plus 2 over pi times, it's going to be multiplied by the summation from n equals 1 to infinity, -1 to the power of n plus 1 times sine n pi t over n. That's where that n comes from there. I could have had it over this one, but this here is just a more concise version of this stuff up here, right? And we use this structure here to account for the switching positive and negativity. So you just have to do a lot of struggling through it yourself. Hopefully you'll have picked up bits and bobs there you can use across any question of this nature in the exam papers.